Hi everyone, welcome to my channel. Today we're going to be solving a programming question called longest common subsequence. This is a medium level question and the problem description goes like this. Given two strings, text 1 and text 2, return the length of their longest common subsequence. A subsequence of a string is a new string generated from the original string with some characters, and it can be none, deleted without changing the relative order of the remaining characters. So for example, ACE is a subsequence of ABCDE, while AEC is not. And you can skip some letters if you want. A common subsequence of two strings is a subsequence that is common to both strings. If there is no common subsequence, return 0. The examples are text 1 is ABCDE and text 2 is ACE, and output is 3 because the longest common subsequence there is A, C, and E, and that is of length 3. And in the second example, the first text is ABC and the second text is ABC, and all three letters are their common subsequence, so the output is 3. And in the third example, text 1 is ABC and text 2 is DEF, and there is no common subsequence between those two texts, so the output is 0. To solve this problem, we're going to use an approach called dynamic programming. So here we have an example. Suppose we want to see what the longest common subsequence between the string ABCDE and the string ACE is. We're going to have to check the last character in both of these strings and see if they match. If they match, that means that there is at least one character that is part of the longest common subsequence. So we can add it to our result. And after that, we're going to break the problem down into subproblems. We're going to chop the last character on both strings off because we know that it's already equal to each other. So then we'll find the longest common subsequence between the two strings with the last characters chopped off, which in this case is ABCD and AC. Now, if the last characters of the two strings do not match, we're going to have to compare the longest common subsequence between the first string with the last character chopped off and the second string unmodified, and the longest common subsequence between the first string unmodified and the second string with the last character chopped off. And then we're going to continue doing this until we can't compare any more characters and we find our solution. So here's the table we're going to be calculating. Any string, when compared to an empty string, is going to have a longest common subsequence of 0 because there is an empty string and there cannot be any common subsequence with it. So that's why we have zeros over here, and that is going to be our base case. And then we just compare. We'll compare the A in ABCDE with the A in ACE, and there's a common letter there in the very last letter, so it's going to be 1. And then we'll compare AB in ABCDE and A, and there's no longest common subsequence there in B and A, but there is a longest common subsequence when we compare it to A and A, and then we'll compare it to B. And so we'll get the max of that, and it's going to be 1. Then we'll continue doing that until we get to the end. And in the end, it would be 3. If we did this recursively, this previous value, A and A, would have been computed twice. So instead of doing it recursively, we're going to store it in a table, which would make it dynamic because we're not going to recompute those values. We're just going to go look up the table and then get the value from the table. Now let's code our algorithm out in Python. The first thing we're going to do is find the length of the two texts. So length 1 is equal to the length of text 1, and length 2 is equal to the length of text 2. And now we're going to declare our 2D array, which will store all of our values. And this will be our results. We're going to go through all of the characters in length 1 and length 2. For I in range length 1 plus 1, and for j in range length 2 plus 2 plus 1. We're going to see if I is equal to 0 or j is equal to 0, and that is going to be our base case. Basically, if they are empty characters, we're going to set the result to be 0. If I is equal to 0 or j is equal to 0, then results at I, j is equal to 0. Otherwise, we're going to follow our algorithm and we're going to see if the last characters in the two strings are the same, and if the last characters in the two strings are the same, we're going to store that in the results. We're going to add 1. So if text 1 at I minus 1 is equal to text 2 at j minus 1, we're going to add it to the results, which is results at I of j, and it's equal to the previous results, so results at I minus 1 and j minus 1 and plus 1. And we're also going to have to check and see if the characters are not the same, and if the last characters in the strings are not the same. We're going to have to start chopping the characters off and comparing the longest common subsequence between the first string with the last character chopped off and the second string unmodified, and the longest common subsequence between the first string unmodified and the second string with the last character chopped off. To do that, we're going to have an else statement and refer back to our results. So our results of I and j is equal to the maximum of results of I minus 1 and j, or results of I and j minus 1. Because this is already computed before, as we saw in the table, and so we're just going to refer it back to the results table. And now we're going to return the results at text 1, at length 1, and the results at length 2. Let's run the code. And we'll see that it gives us the longest common subsequence with a length of 3, because abcde and ACE both have a longest subsequence of A, C, and E. So that was our approach to the longest common subsequence. We used dynamic programming to solve the problem. If you like this video, please give it a thumbs up. If you have any questions, please comment down below. Don't forget to subscribe. Thank you guys so much for watching, and see you in the next tutorial. Bye.